Okay, so let's start. And hi, everyone. Thanks for joining us today. And I'm so excited to be here with you today. We are from DeNA, which is one of the largest game publishers in Japan. And today we are going to share our AI implementation on gaming. So far, we have released 2 AI applications, and we're going to talk about the motivation and the implementation and the outcomes of these projects. My name is Jun Ernesto, and I'm leading this project. Also, let me introduce Iki Tanaka. He's a data scientist and built our AI models. In this part, both of us will present. So to begin with, this work has been accomplished by 4 machine learning engineers and lots of collaborators from gaming team. Each of us have our own area of expertise, and I really love this team. So let's start. I think most of you are not so familiar with DeNA. Our company is one of the largest internet companies in Japan. Although we have various business domains such as game, automotive, and life science and sports, most of the revenue comes from games. Actually, we are providing dozens of in-house game titles and other publishers' titles. And maybe some of you may know that we have an alliance with Nintendo. For example, our company is in charge of the backend system of Super Mario Run. So this is who we are. So in the sessions, we'll focus on the in-house game title, Gyakuten Othellonia. So first, I'd like to talk about the problem we had and how we challenged to solve these issues. So this game, Gyakuten Othellonia, is a strategy up game. The player's action is based on the board game called Othello or Reversey, and the player put black and white pieces alternatively. And what is unique about this game here is that each piece has its own skills, which adds strategic components to the battle. Actually, when you start playing the game, there are varieties of play styles, and endless exploration is required to master the game. So this title was released 3 years ago, and fortunately, it's still growing. We have more than $24 million so far, and the service region is expanding gradually. Of course, I hope in the future we can release it in the US as well. So in Othellonia, there is a concept of decks and characters. So before starting the battle, player constructs deck, which is composed of 16 characters among more than 3,000 options. And each character has its own skills, and the players have to choose consistent characters according to their play styles. As you can imagine, the number of the combination is extreme, and it's very hard for beginners to learn how to build optimal decks. Another issue here is that building an optimal deck requires to learn effective strategies through the process of trial and error. So let me explain why this is a problem. So generally speaking, if the game is complex, game has complex features which can distract players from continuing the game, the churn rate increases and impacts the future revenue, right? And for example, there is an estimation that just a few points decrease in the 30-day churn rate can increase the revenue by 20 to 30% in the future. So back to Othellonia, we actually have a high churn rate, so we have trouble here. And this is partly because the game is complex and lacks sufficient onboarding support, and therefore it's hard for beginners to construct the optimal deck. Right. So also there is a problem that they don't have a good place for practice in order to improve their play skills. For instance, we only have 2 battle options for beginners. One is NPC battle, which they battle against a very, very weak opponent. And the other is a PvP battle, in which they are frequently matched against very skilled or experienced players. So we needed an opponent whose play level is similar to the beginners. So here's our approach. To support beginners, we have provided two functions. The first one is the deck recommendation system, which selects appropriate characters from players' piecebooks. And we are using association analysis to provide a better recommendation. The second one is Battle AI, which we call Othellonia Dojo. And in these functions, we have developed AI that can play at any levels. A deep neural network is used for this AI. Later, Iki will explain how these techniques are used in our cases. Okay, so by the way, from the machine learning perspective, we need to prepare data to build such AIs. We are collecting various kinds of in-game data since the release of the game, such as deck logs and battle logs. So we had a good amount of data when we started this project. And in our cases, we use the data for the last 9 months, which contains billions of log entries. Then we filtered the data by player skills and augmented the original data in the battle AI cases. The image on the right side is an example of battle logs, which is formatted in JSON and describes entire state and action information of the battle. And the bottom diagram shows rough data pipelines, and BigQuery did a very good job at this pre-processing phase. For instance, it can handle even terabyte order of data very fast, and we could reduce the processing time drastically. BQ could handle our data in a few minutes and well, compare with on-prem Hadoop clusters that took like an hour. So yeah, we are very, very happy here. And we also love that BQ is easy to collaborate with another GCP services. And here I want to stress that our AI has been successfully built by sufficient amount of data and reliable pipeline. So let's see how each of these use cases works. This is a rough overview of deck recommendation system. So we first exploit preprocessed deck logs to extract information about how each characters are associated, which we call association rules. With this analysis, we can score the strengths of the relationship across all the pair of characters. If there is a request from the player, the recommendation server responds. The set of receive a set of characters in the player's spacebox, and it fills all the 16 characters according to the score of association rules. This function is very flexible, and the player can specify deck archetype and deck cost, and also the favorite characters to be included in the deck. Regarding KPIs, we're monitoring several metrics. For instance, we're watching how many players have used this recommendation system and whether the recommended deck has been accepted or whether the deck contributed to the players in terms of win rate at battles. As for the dojo, player can battle against AI with various archetypes and strengths. So here we train a deep neural network from preprocessed battle logs. The client sends current game status, and the battle API server returns the inference of neural networks at every turn of the battle. And as for the metrics, we're monitoring how frequently the dojo is used for beginners and whether the strength of AI was sufficient in terms of win rate. So these two AIs have already been released, and we are observing positive KPIs. And before showing the results, I want to pass the talk to Iki, and he'll talk about the technical details and some tips for building AI.
Hi everyone, I'm Iki and a data scientist at DeNA. So I'm one of the developers that created our gaming system by using machine learning and data science. So today I will talk about the technical details of our use cases with GCP. So Now, let's look at the story of the technical part. First, I'd like to start by the deck recommendation. This is the outline of the deck recommender algorithm. Firstly, the algorithm receives some inputs from a player, such as the deck archetype, deck cost, the possessed characters, and the characters the player wants to use. Next, the algorithm selects a leader by using the result of association analysis and the statistical data. In this algorithm, the leader character is chosen first, and the next characters are selected based on the leader. The well-associated characters are simply selected based on the result of association analysis. If the deck is not full of 16 characters, another character is selected based on the character as a base character. After repeating this procedure several times, the recommended deck is proposed to the player. If the game is different, the way of fine-tuning is also different. In our game Gyakuten Othellonia, for example, we made additional rules to decide a leader, and we ignored the characters whose skill will be never activated in the deck. I'd like to give a brief explanation about how to extract the relationships between characters. In our recommendation, we are using the association analysis. The association analysis is a rule-based machine learning method for discovering meaningful relations between contents in large dataset. This method can perform high-speed calculation to extract the many rules, and the extracted relations are easy to understand and useful in various settings. The relations are evaluated with some metrics like the strength of the connections and the frequency of the rules and patterns. Our recommendation builds a deck by selecting the characters sequentially with strong relationships, one after another. This method can handle the various kinds of data easily, so this technique is applicable to many games and other fields. Next, I will talk about the system. So we built our applications like the deck recommendation and defining a bot with DCP. So why did we choose DCP for our machine learning systems? There are two main reasons. The first one is that the DCP has powerful and flexible tools for machine learning and data science. In the data analysis, we often try to investigate the data, visualize it, and create the prototype models. The DCP services for the big data analysis make it possible for us, such as BigQuery, Cloud Data Lab, and Google Compute Engine. And cloud storage provides a scalable and fast storage service for large data, and it helps us to manage the big data and a lot of machine learning models. About Cloud ML Engine, we can deploy the AI models to Cloud Machine Learning Engine easily and quickly. And it also provides user-friendly APIs. Additionally, DCP provides many services to perform the machine learning efficiently. For example, we are trying to use GK container service and Cloud ML Engine training with custom functions for scalable and distributed ML trainings. The second one is that the GCP has scalable and robust infrastructure services. We can run the applications easily by using Google App Engine with several programming languages like Python and Go languages. And we can check many metrics through Stackdriver, logging, and others. I'd like to emphasize that the auto-scaling of the Google App Engine is a very great service because the new instances are increased or stopped in response to traffic, and the requests are distributed to the instances automatically. These DCP services are easy to integrate into the same system. Moreover, although I don't touch on the product details, Google Cloud brings many advantages to our business, like the security, collaboration, and openness. For these many reasons, we are choosing DCP for ML systems. Next, I'll show the system architecture of the deck recommendation with GCP. The deck logs are saved in BigQuery, which are used to extract the rules. We set the cron scheduler to perform the batch processing of the association analysis in Google Compute Engine. And in order to catch up the trend decks with latest characters, we are performing the batch processing every day. Then Cloud Functions preprocesses the result of association analysis and updates the data for production environment in GCS. Cloud Function checks if the data is updated correctly. For example, if the data size is too small or large. Then we are using Google App Engine Python 3.7 for our recommendation API server. The server receives a request from the client, then builds a deck using analyzed data, and finally it returns the recommended deck to the player. One of the noteworthy points is that GAE Python 3.7 was generally available at the end of last year, so we could use it just at the right time. As a result of upgrade to Python 3.7, we didn't need to change our code that we had already developed in Python 3. So far, I've explained the algorithm and the system of the deck recommendation. Let's move on to the next topic, deep learning AI bot. It's called Othellonia Dojo. Dojo means a training room to improve playing skills. This is an overview of the training in deep learning AI bot. Deep learning was suitable for our case to learn many complicated features such as the state of decks, boards, hands, status, and the combination of the features. The deep learning AI bot receives the state of battle from the client. The information of battle is converted to the numerical features, which are used as the inputs of the deep learning. Here, we created more than 5,000 features. The network learns the actions of top-tier players as binary classification. Finally, the deep learning model outputs the values of each action that will be used to decide the next action. We used more than 10 million battle records in the training. In our training, we are using the battle records of highly skilled players, but we needed to create the AI with appropriate skills for beginners. In order to divide the strengths of AI into multiple levels, we are processing the inference results. Specifically, we select the highest evaluation value when we want to make a strong AI. And if we want to weaken the strength of AI, we select the second or third values with a probability. Technically, the probability is calculated by softmax function, which transforms the values into the probability distribution. After tuning the probabilities, we made 5 levels of AI. In the latter part, we will show the remarkable results of the winning rates against the actual players. Next, I will show the system of AI bot. First of all, I'll talk about the training phase. A large number of battle records in PvP is saved in cloud storage through BigQuery. The training process consists of the pre-processing of the features and model training, which are running in Google Compute Engine. As the pre-processing, the features are generated on demand by emulating the game. In our case, we created the custom function of data generator that creates the features during the training. After the training, the trained AI model is saved in cloud storage to deploy onto the cloud ML engine. Regarding the continuous integration and delivery of machine learning, it's so-called CI/CD, we are testing the training modules to check the dependencies and features automatically by using the unit test and regression test. Also, it is important to deploy the AI model automatically in short cycles with high reliabilities when releasing new models. We are currently trying to simplify the complicated process from training to deployment by using CI/CD tools for executing it more quickly and easily. I think we can leverage the cloud build, the continuous delivery service of GCP, to accomplish better CI/CD. I'll move on to the inference phase. Please take a look at the communication between the client and the inference API server on the left of the slide. The battle records are posted to the inference API server from the client who is playing against the AI bot. The inference API server reproduces the battle from the record, then extracts the features, and it sends the features to the online prediction API of the CloudML engine. Online prediction of CloudML engine is very useful because it is optimized to run the AI model with low latency in real time. CloudML engine uses a trained AI model stored in cloud storage and returns the values of each action. The values are sent back to the client, and the client moves forward the battle step by selecting the best action according to the values. That's the overall communication between the client and the server. App Engine and CloudML Engine can autoscale in response to the traffic. That's a very good function. By taking the benefit of the autoscaling, we can manage a large amount of requests. Lastly, I'll touch on the technical topic, the testing of the systems. So why should we test the systems? I mentioned in the last slide the CloudML engine can autoscale. That's good. Yes, that's true. But we didn't have enough knowledge about how much load the system can withstand. In the mobile game, generally, the load tends to increase at the moment a new event opens. The figure of the slide shows the example of the estimated request per second in a realistic event. This is a trial calculation that the request per second will increase to 700 in 10 minutes. We have to check in advance if the system can withstand like this load. As a point to be noticed, we cannot predict the action of AI as a batch processing at regular intervals. Our system has to respond to the request in real time. That is where the AI should put the character in the next turn. To achieve this, we chose the online prediction of the CloudML engine. We've checked if the CloudML engine can satisfy our requirements by performing the load testings in advance of release. In our case, the testing was performed in the setting that the requests increase linearly and reach a maximum of 1,000 requests per second. We found that CloudML engine can scale quickly in response to the requests, and the average latency of the prediction is less than 1 second. However, there were a few requests that took a longer time than usual. Since this might not be possible to return all the requests to the player quickly, so we needed to resolve this condition. Our team and CloudML engine team cooperated to investigate the bottlenecks. Then we found that the timeout had happened when the new instances warmed up in the process of the autoscaling due to our heavy load. It was challenging to handle a large number of requests, which consist of many features at the same time with online prediction. But if we can resolve this problem by building an efficient backend system, we don't have to warm up the system beforehand, and the system will be more robust. So our team took a time to deal with this problem. Let's take a look at how we tackle to remove the errors. When the error returns within the time, we can simply throw it back again to the API. But in the case of timeout, the system cannot send it back again because the timeout error is not returned. Therefore, when the Inference API server does not receive the response within 5 seconds, the request is sent back to the API again because something bad has happened in the inference. Also, if the destination of the request is the same endpoint, it will further increase the load on the server. As a result, we set another backup endpoint to receive the request that fails to be operated in the main endpoint. That is, the second request is sent to the backup endpoint, which is prepared independently from the main endpoint. This is a result of the load testings with the backup endpoint. The figure shows the total error rates of several settings. No backup, backup with 10 minimal nodes, and the backup with 20 minimal nodes. In the case without backup endpoint, on the left, about 1.3% of errors remained. In the middle setting of the backup with 10 minimal nodes, although small errors still remained, the backup can deal with most of the main endpoint errors. We found that the reason of this small error was because the number of backup instances was small. So the timeout had still happened as the warm-up of the auto-scaling in the backup environment. The rightmost case is a fine-tuned setting where the number of backup instances was set to 20 for covering the main endpoint errors sufficiently. In this case, we could handle all the requests without errors. In this way, DeNA and the CloudML engine team got over the challenge, high and spiky traffic, and latency limit without errors. After deployment in this setting, the system has been stable in handling many requests. Let me show you one more thing. It's a useful service to monitor the system performances. We can check the server performances through Stackdriver, which provides error reporting, alert notification, logging, trace of latency, and many others. Stackdriver dashboard especially provides a visualization tool that is easy to add charts and customize it. We are monitoring the many metrics according to our needs in the one place. For example, the number of requests, API latencies, CPU and memory usage, and the number of running instances in real time. Additionally, you can change the time window to focus on and check the percentile values. We are using 99 percentile values for anomaly detection in the system. So far, I have explained the technical details of our AI with DCP. The system with DCP can be constructed flexibly to cope with various problems in gaming and other fields. Now, I'd like to hand over to Jun for the KPI result of our use cases and the future. Thanks.
Okay, so this is a result part. Okay, so as Iki mentions, we needed a scalable and robust system to successfully release our AIs. So in this final part, we would like to share what happened after the release. So first, for the deck recommendation, here is a chart which shows the number of beginners who use deck recommendations. There were constant usage after the release, but this function was not well known at this time. But the situation has been changed after we started an in-game event to promote players to build new decks. So the deck recommendation system has been recognized more, and even after the event has finished, many players and mostly beginners are still using this function frequently. So second, we are very glad that the recommended deck pushed the win rates of the beginners by about 5% compared to deck created without the recommendation. So since our focus was to support beginners, we are very satisfied with these results. Also, I'd like to mention that this function has good adoption even for top-tier players. This was sort of byproduct, but we are observing that the heavy players usually update their deck frequently, and this recommendation system mitigates the cost of building deck from scratch. They use recommendation as a first suggestion, and then customize the deck as they want. So let's see the system metrics as well. After the release, we have a stable latency of 20 millisecond, which is fast enough for our cases. And we're surprised by the result because the recommendation algorithm is very complex, and we haven't expected such a low latency. So the auto-scaling does a good job, and we haven't had any system trouble so far. So briefly, we will explain about the evaluation of deep learning AI bot. After the release, we are observing that our AI bot has good enough win rate as a practice partner for beginners. So this chart shows that the win rates of AI against players. The horizontal axis denotes the player's skill levels, and the vertical axis is the win rate of AI. So in the Dojo, we provide 5 different AI levels, and the strongest one can even beat the top-tier players with a win rate of 50%. So we think that our AI is strong enough for beginner support. So from beginner's perspective, win rates of AI ranges from about 20% to 8%, which means that the player can choose any, appropriate levels of AI according to their skills or preferences. So therefore, this AI works as a sort of good mentor. Although this was released last month and we don't have enough data to evaluate the business impact, Dojo is used by beginners very well, and we hope that this can lead good KPI in the future. And as for the system metrics, the inference of cloud machine learning engines is about 200 to 300 millisecond and very stable. Even for the entire system, the response time is about a second, which is enough fast for our case. And backup endpoint is working well, and we don't have system trouble so far. So at the end of my talk, I'll show items which worked in our cases. So first, to train the AI that play the game like a human, we need the battle logs that completely reproduce battle status and actions. So if you have some random effects in the game, make sure that the random seeds are stored in the logs. So secondly, for the evaluation of our AI, we needed to run thousands of battles to get performance statistics. So a headless simulator helps us a lot in this context. And well, if you want to try to use reinforcement running techniques, you also need to very very fast simulator, because the number of the battle the algorithm goes through really matters. And the third, we also want to stress that the scalable and robust system is critical for implementing AI in real services. We think that GCP, in particular, Cloud Machine Learning Engine and GAE were a good choice for us. And as for the CI/CD, we have to think about how frequently or by which trigger the AI model should be updated. Because the game environment changes frequently, we need to keep, adding features and retraining the models after the release. So this operation is very heavy, and we have to think about the CI/CD before the release, in particular in the AI modeling phase. The final item is not technical but critical. Generally speaking, we don't know how well AI will perform and how big the business impact will be before starting a project. So in such an uncertain case situation, the communication and controlling the expectation is very, very important. Although we are machine learning engineers, we try to understand the game and the business issues correctly. And I think that this was a key factor of the success of this project. So that's all from me, and I'd like to pass the summary to Henry. Thanks.
Great job. All right. So hi everybody, I'm Henry Tappan. I'm a product manager on the AI platform team working on what was formerly known as the Cloud Machine Learning Engine, but we've just rebranded to be the AI platform. This was a really exciting thing. So we've been working with the DeNA folks for a while for this one, mostly being inspired by the very elegant way that they took a number of machine learning techniques and built an awesome experience for their beginner gamers. Now, when we saw this, we noticed there was a lot of different things that they had to use, a lot of different pieces of technology between App Engine, Compute Engine, the Cloud Machine Learning Engine, and so on and so forth. So the challenge to us at Google is how could we make it even easier for teams like DeNA or other gaming companies to get started even faster producing these kinds of innovative but also very accessible gaming experiences for it using things like machine learning and AI. So we've been working on a number of features to make the process of getting started that much easier and that much simpler. So one of the ones that we noticed was starting to think more about machine learning beyond just TensorFlow, Scikit, and XGBoost. So Cloud Machine Learning Engine was one of the first cloud-based platforms that enabled you to train a TensorFlow model in the cloud. Since then, in the last few years, we've added support for other libraries like scikit-learn and XGBoost. But especially seeing what was done with association rules and other data mining techniques, we realized that the world of the world and the problems are much bigger than that, which is easy to do inside of these frameworks. And so we've been working on introducing support for custom containers into our training component. This is now available in a public beta. We expect to go to full release probably in this quarter, but certainly inside of 2019. Where with custom containers, you can take any code, any framework that you can stick inside of a Docker container, and then push it to the Cloud Machine Learning Engine in the same way that you would use TensorFlow models or Scikit or XGBoost or any other kinds of training scripts. So this gives you access to not only traditional machine learning frameworks like TensorFlow, PyTorch, Caffe, etc., but also to run any other software that you might need. So if you've written some C++, some Java code, some different Python routines, even R code for solving certain parts of your analysis or production of models, you can now go ahead and easily train them on the Cloud Machine Learning Engine. Additionally, it's not shown on here, but we've also been thinking more about how we get easier pipelines for solving some of these things. So late last year, we released into the open source a system called Kubeflow Pipelines, which is a composition and an orchestration engine for running machine learning focused workloads. On Kubeflow Pipelines, you can start up a Kubernetes cluster on GKE or on your own premises, etc. Specify a simple workflow that says all the different steps you'd like to do on the way, including training jobs on the Cloud Machine Learning Engine. And then the Kubeflow pipeline system will take care of doing all the steps necessary, making sure that it runs effectively. So this could be a great way for tackling bigger parts of your machine learning workflow besides just the actual training part at the very end of it. So the second thing that we were really inspired by and have been working on is, I think Jun-san pointed out very, very well that and Ikki as well, that when predictions come back from the machine learning framework, or as you're putting data into the systems, you often need to do other transformations to make it compatible for the game. So coming back to the example of the AI, it wasn't enough to just get a particular score back from the model, but you also needed to select, based on the player's skill level, a random choice of a different option in it. Now this could be really hard in that you might have to set up different servers for post-processing or pre-processing the data before you send it to the machine learning engine. So to make this simpler, we have available as of today in beta the ability to run any Python code on the Cloud Machine Learning Engine prediction service before or after you make any predictions. So if you need to reshape some data, maybe take a different result, convert from a score back into label, so on and so forth. It's now just as simple as giving us a Python class, and you've got whatever you need to make happen along the way. This incidentally also gives you some more flexibility as well. We allow you to install any Python packages on the Inference server as well, and then do whatever you'd like with inside those packages. So you have many more options for running jobs on side of our machine learning systems. And then finally, the other big advancement that we've seen that was, I think, especially relevant for gaming, and one thing that was inspired by DeNA, is giving better flexibility and better capacity for it. So, it's really great to see heavy usage of our systems, and we want to make sure that we're giving you exactly the capabilities that you need, that you're able to run your jobs bulletproof, even for when you have high demand, bursty instances for it. So today in the machine learning engine, on the prediction side, you're able to choose either a 4-core or a dual-core machine with a choice of RAM in there. We're expanding this range of options to be virtually any machine type that's supported on Cloud Machine Learning Engine, or sorry, that's supported on the Google Compute Engine, and including into this support for accelerators like GPUs. So that way, if you've got a job that is very intense, or very bursty, or you want to maintain a certain level of latency, you're now able to select many more machine types and much more power to those ones. Especially for those who are looking for really complex models like reinforcement learning, or you're trying to beat the next StarCraft AI, this might be a great option for you. So let's kind of sum up with these things. This was a chance for us to see that AI can be used for much more than recognizing images or speech or something, but we can actually use machine learning AI to create compelling gaming experiences, both to challenge our players for when we want to give them a smarter AI, but also to assist them so that beginners have an even playing field with those who have been on it for a long time. And the result of these kinds of experiences can result in better engagement and revenue for your game. And then finally, to note that Google Cloud is here to help. We're very interested in the gaming segment. We're very interested in machine learning. So anything that we can do to help you achieve success in your gaming, we're happy to do it.